This lecture is your introduction to COVID-19. So the basics then are that the disease COVID-19 is the basis of our current pandemic. And COVID-19 then is caused by the virus, which is called SARS-CoV-2. Also sometimes called the novel coronavirus. So I want to give you a whole bunch then of coronavirus information. And I'm going to start with the absolute basics. What is a virus? So, what then is a virus? And a virus is a particle, basically, much smaller than a cell. This is something you really have to keep in mind, how tiny these things are. So, for comparison, then, a cell like one of ours, that's an OV there, a cell like one of ours, and these are known as eukaryotic cells. So a cell like one of ours will be about 10 to 100 micrometers or microns in diameter. A bacterium, which is a prokaryotic cell, is about, and these of course can vary widely, but I'm just giving you some approximate things here, is approximately then from 0.1 to 5 microns then in diameter. And SARS-CoV-2, then, this virus is pretty big as viruses go. That is to say, about 120 nanometers in diameter. So much, much smaller. So this is much smaller than most bacteria. But large for a virus. That is to say, it is about 0.12 microns. So just to kind of give you an idea, let's say that this is a cell like one of ours, you know, a skin cell or a lung cell or anything like that. Okay, so there we have a cell like ours. And, oh, I don't know, maybe something like that. That might be your basic bacterium. And then compared to that, that's going to be some virus or other. So we are talking about huge differences in size. So a virus then basically is either DNA or RNA surrounded by an envelope. Something basically around its outside. And I'm just going to say, but they may have other features as well. So viruses basically have a parasitic relationship. With cellular life forms. So the cellular life forms may have cells like ours, or they may be bacteria. A virus then will basically invade a living cell and take over the cell. And this happens a number of different ways. But the result then is that the cell's ability to reproduce, this is kind of the crucial bit here, the cell's ability to reproduce is taken over. So the cell is no longer going to reproduce new cells. So the cell's ability to reproduce is taken over, and the infected cell then produces new viruses instead of new cells. So now that cell has basically been converted into a virus-making machine. And the cell may die from this invasion. And take over. And then once all those new viruses are produced, they escape and take over other cells. And on and on and on it goes. The viruses just keep reproducing courtesy of other cells, or rather, I wanted to say other cells, courtesy of cells that they invade, courtesy of that machinery. Remember, viruses are not cells. So now you know what a virus is. Let's talk about this special bunch of viruses known as coronaviruses. So coronaviruses are called this because their outer coating has lots of spikes, basically. And the spikes end in blobs. And it looks sort of like a crown or corona. And so by now you're pretty used to what a coronavirus looks like this. So you have the spikes ending in the blobs. You have this sheath here. I'm going to talk more about this sheath in a while. And then on the inside, you have some RNA. This coronavirus, I should say, is an RNA virus. So SARS-CoV-2, the virus we're worried about right now, also has a lipid, and this turns out to be important, a lipid envelope. So this here, then, that is the lipid envelope. Basically, the lipid envelope is what surrounds the interior of the virus, and these, of course, are the spikes. And the fact that the interior of the virus is surrounded by a lipid winds up coming in handy for us in certain ways. So it has a lipid envelope then. Sort of like a cell membrane. I hope you remember that cells have the lipid bilayer as the basis for their membrane. So the lipid envelope, then, means that substances that can dissolve liquids or lipids, substances that can dissolve lipids, then, can break up this envelope and destroy the virus. And this is how most useful antiseptics, and I'm now talking about things that are applied topically, things that you would put on your hands, for instance. So this is how most of the useful antiseptics against this virus work. They dissolve or break up the viruses lipid envelope. So these are all of the disinfectants that you've heard of that you can use to clean surfaces, to disinfect your hands, and the like. So these disinfectants then include alcohol, ammonia, chlorine, and soap. That's why we were told to use hand sanitizer. That's why we're told to wash our hands with soap and water, because anything like that will basically break up that lipid membrane. Anything that will dissolve a lipid, and you can think of lipids are related to grease, basically. So if you can think of all those things that will dissolve grease, you're at least getting a handle on what will dissolve a coronavirus. So SARS-CoV-2 is an RNA virus. So remember what I said before, a virus is basically a nucleic acid, either DNA or RNA on the inside, and then you have around it some kind of an envelope. In the case of SARS-CoV-2, there's RNA on the inside. And I'm going to give you a quick note here, things that are important here. In case you were wondering, antibiotics do not work on viruses. Antibiotics only work on diseases caused by bacteria. That's important to know. And that's the end of this lecture.